Okay. What was the last thing we were learning? We have done this math, right? The power dissipated PZ. We have done this math, right?
Yes, sir.
Okay. Today we will be doing the fixed VI and variable RL math. Fixed VI and variable RL. This thing we have done already? No, no, not yet, right? Okay. Here, your VI should be fixed, but your RL should be variable. What is RL? RL is the load resistance. The load resistance that will be variable. So you will be finding out the maximum and minimum resistance so that the diode remain open, or not open. Actually, diode remain on. Your VI should be fixed. Here, uh, which one we do? Let's write the formula or let's do the math. Which one? Okay, let's see the formula first. Okay, so here let's let's draw a circuit first.
Hello, sir.
Yeah, I'm doing it. Can you see that?
Yeah, I can hear you, but right now is okay.
Okay. I was not talking. I was just writing. I was just drawing.
Uh, okay.
Okay, now see, I have to show you something. Now here, I have drawn a circuit. Here your VI is fixed. Okay, it will not change. It will be remain like this. Your RL is this one. This will be variable. That means you have to find out the minimum RL and the maximum RL. How much RL you can use. Now all we know, this is VR, this is VL, this is VZ. When the Zener diode is on, that means VZ and VL, they are actually same, right? That time this current is called IR. This current is called IZ. This current is called IL. When the Zener diode is on, just on, that time your IZ will be 0 and IZ has a maximum value as well. What is that value? That maximum value is called IZM. That is maximum current. Okay, that can sustain. If you exceed that current, the Zener diode will be destroyed. That's why you have to keep that current in mind so that the Zener diode current never goes like that. Okay, that is the maximum Zener diode current. Now, as we know, our what is our VL? What is our VL? What is the formula of VL? The formula of VL is this one. VL is equal to VZ is equal to the formula from the voltage divider. RL into VI divided by RL plus R, right? RL into VI divided by RL plus R. That is the VL formula. Now from here, if we find the RL, from here, if we find the RL, that is this one, we will find the value of the minimum, what? The minimum RL, minimum. Why minimum? Because RL, VL is equal to 10 volt or VZ, VL is equal to VZ when the RL is minimum. That's why RL minimum is equal to R VZ VI minus VZ. Okay, understood? That is the minimum. That is the minimum RL. If we got the minimum RL, that means you have the maximum IL. Minimum RL means minimum resistance means maximum current. Minimum RL, that means you will get the maximum current. What is that? IL maximum is equal to VL divided by RL. That means actually RL minimum actually. Got my point? If you IL is equal to VZ divided by RL. So if RL is minimum, so this will be maximum. Okay? Remember why? Because RL is at the bottom side. So if it is minimum, so it is maximum. That's why. Okay. Now you got the IL minimum. What about the VR? VR formula is equal to VR equal to VI minus VZ, obviously. So what is IR? IR is equal to VR divided by R. Now, according to the formula, we know IR is equal to IZ plus IL. We know it, right? Now here, if IR is fixed, why IR is fixed? Because VI is fixed. If VI is fixed, that means VR is also fixed. Okay, VZ is fixed. So this current is fixed. This current do not have any maximum minimum. Now which one has maximum minimum? This one has maximum minimum. This one has maximum minimum. Okay. So if this is maximum, this is minimum. Or in other words, if this is minimum, this is maximum. So from there we can see, from here, we can take it at this side. So IR minus IZM, that is maximum, equal to IL minimum, right? If you know the minimum, can you find out the RL? RL is equal to what? V divided by I, right? What V? VL. That means VL and VZ, they are actually equal because they are parallel. So VZ divided by IL. Now, if what we have found the IL minimum, right? So if I give minimum here, we will get maximum. So that is the range, RL minimum and RL maximum. Okay. So let's do a math. This will be clear to you if we do the math. This is the math. For the network in the figure, find the range of RL and IL that will result VRL maintained at 10 volt. That means here you will get 10 volt. Okay. This 10 volt will not be smaller than 10. This voltage will not be bigger than 10. Why it will be smaller than 10? Because when the Zener diode is off, that time this voltage will be smaller than 10. When the voltage will be bigger than 10, when the Zener diode is destroyed, that time. So you have to maintain the voltage at 10 volt. Understood? So let's find out. Okay, now everyone see. First, which one I have to find out? We have to find out the RL minimum. RL minimum is the formula. What is the formula? Before finding out the formula, that was the formula we have found out earlier. So we can actually write the value. R is equal to 1K, VI is equal to 50, VI is equal to 50, and VZ is equal to 10. What is the value? If you use the calculator, it is 1 into 50 divided by 50 minus 40, 50 minus 10, 1.25. 1.25 kilo ohm. Now, what was the formula actually? Oh no, the formula was VZ. The upper one is VZ, not VI. The upper one was VZ. You made a mistake. R is equal to 1K, VZ is equal to 10, lower one is 50 minus 10. So your formula is actually 0.25, 0.25. Kilo ohm, or we can call it 250 ohm. Okay, that was the formula, that is the value, that is the minimum value. Now if you got the minimum value, you can obviously find out the maximum current, because minimum resistance means maximum current. Okay, now how to find out? VL divided by RL. Since this is maximum, it should be minimum. In place of VL, we can write VZ. VZ is equal to 10. RL minimum is equal to 250 ohm or 0.25 kilo ohm. Ten divided by 0.25, your value is 40 milliampere. Why milli? Because this is kilo, that's why milliampere. That is the maximum current you can get. Now remember, your IZM is given also, that is 32 milliampere. Okay, now we have to find out the VR and IR. What is our VR? VR is equal to VI minus VZ. VI is equal to 50, VZ is equal to 10, so you get 40 volt. What is your IR? IR is equal to VR divided by R. VR is 40, R is 1 kilo. So this value will be 40 milliamp. Okay. Now we know IR is equal to IZ plus IL. And remember, if this is maximum, that means if this goes up, this definitely go down. Or in other way, if this goes down, this definitely go up because this value is fixed. Okay, so that means if this value is minimum, that means we already find out the maximum one, right? We do not have to find out any anymore. We have to find out the minimum. So if this value is minimum, definitely this value is maximum. Understand? So from here, which one we know? We know IR. We know IZM or IZ maximum. Where? It is given in the question. We have to find out the IL minimum. So how to find out that? Keep it here. Take that on the other side by subtracting. So your value will be IL minimum is equal to IR IZ maximum, that means IZM. IR is equal to what? IR is equal to 40 milliamp. My IZM is equal to 32 milliamp. So your value is equal to 8 milliamp, right? Now, which one you already found out? You found out the RL minimum, IL maximum, and IL minimum. So we out of four value, we already found out 3. 4 value means this RL maximum minimum and IL maximum minimum. Okay. So which one we haven't find out? The RL maximum. Again, formula of R is equal to V divided by I. What is V? V is equal to VL or VZ because that is fixed. What is I? I is equal to IL. Now remember, when you are finding out the maximum resistance, you have to use the minimum current. Got my point? Minimum current means maximum resistance. So VZ is equal to 10 volt and IL minimum is equal to 8 milliampere. So 10 divided by 8, 1.25. No, kilo ohm, sorry, not milliampere. Okay, so what is your range now? Your range is this one. RL range is 0.25. No. RL range is 0.25 kilo to 1.25 kilo. IL range is 8 milliamp to how much? 40. 40 milliamp. That is the answer. So one range, another range. Understand? Understand, my dear?
Yes, sir.
Hello?
Yes.
Okay, you got it?
Yes, sir.
Okay. Okay, see the math, we already got that. Oh, the second question, they said determine the maximum wattage rating of the diode. Maximum watt rating. Wattage rating. So what is rating? What is rating actually? P, power. We know power is equal to V into I, right? Now here we have to find out PZ. So VZ into IZ. And they said maximum. So maximum means something has to be maximum. Now VZ do not have any maximum minimum. VZ do not have any maximum, do not have any minimum. It is VZ. But IZ has a maximum minimum, right? So can I call it IZM? So can I call it PZM? That is we have to find out. What is VZ? VZ is equal to 10. What is IZ? IZ is 32. This is okay. This is volt. This is 32 milliamp. So they will give you 320 milliwatt. Why? Because volt and ampere, they become watt. And since you have a milli, so it is milliwatt. Okay, understand? See, 332 milliwatt actually. Now, next one will be fixed RL and variable VI. But before that, let's do one example. You do one example, okay? What is the page number? Page number is 97. Okay, question number 42. All of you do it. Take 5 minutes of time and do it, okay?
Now.
Yeah, now. Okay, and send the answer in the WhatsApp by taking a photo. Can you do it?
Yes, sir.
Okay, take 5 minutes. I'm going to pause the recording and take 5 minutes, okay?
Okay.
Remind me to unpause or resume the recording, okay? Okay, let's solve this math. Okay, here they say determine VL, IL, IZ, and IR for the network of figure. If the RL is 180 ohm, okay, RL is 180 ohm. Here RL is given, so you have to find out all the values. Those are actually pretty simple. Let's solve the math. First thing, we have to find out VL, IL, IZ, IR for RL, okay? RL is equal to 180. So how to find out the VL? VL, the formula of VL is equal to
RLB.
VI into RL divided by R
RL.
plus RL. Okay, pretty simple, right? You know
Yes,
it.
sir.
Okay. Now put the value. If you put the value, VI is equal to 20. RL is equal to 180 ohm.
180
R is equal to 220 ohm
plus 180.
plus 180. Remember, if you use ohm, so all the resistance will be ohm. If you use kilo ohm, all the resistor will be in kilo ohm. Okay, remember this. So what is the value?
9 volts.
20 into 180 divided by 220 plus 180. So 9
Three-
volts. Pretty simple. 9.
9 voltage.
Yeah, exactly. Now IL. What about IL? IL is equal to VL or VZ. Okay. Divided by VL actually. At first find the VL, not VZ. VL divided by RL. Now here, one thing you have to understand. This 9 volt is less than 10 volt, right?
Yes.
So the Zener diode is not on yet, not yet.
Yes, sir.
Okay, not yet. Okay. So that's why we have to use VL, not VZ. You cannot use VZ. So 9 volt divided by what? 180 ohm.
0.05 or 0.5.
9 divided by 180, 0.05. Yeah,
Yes.
very good. What? Ampere, right?
Yes, sir.
So if you multiply with 1000, this will be 50. 50 milliampere, right?
Yes.
Okay. Now you have to find out the IZ. What is the IZ?
As BZ divided by BZ.
No, not yet. IZ is the current of Zener current, right? Zener diode,
Yes.
right? See, Zener diode is off. Why Zener diode is off? Because the voltage is how much?
9 volt.
9 volt. Your voltage should be more than 10 volt.
Yes. First we have to find out IR.
Yeah, no. See this one. Your voltage was supposed to be more here. The voltage was supposed to be equal to 10 volt or more than 10 volt. But you got 9 volt. That means this is not enough to turn on the Zener diode. If the Zener diode is
Zero,
off,
zero, IZ.
that means the current is 0. Okay?
Yes,
Understood?
sir. 0.
Because 9 volt is not enough. Okay. Now IR. What is IR?
VR divided by R.
You can write VR divided by R, but here we do not have to. Why? Why we do not have to? Because we know this is the current that will go through here, right?
Yes.
Because nothing is going there, so all the currents are
So
going
same
there.
current.
So same current, 50.
Yes.
You can use VR divided by R, no problem. Okay, this is the question number 1. Now
Yes, sir.
now we have to repeat the same thing for what? 470. Okay.
Yes.
Now we will use 470 everywhere. Where? Let's say here. 470, 470. The value will be changed. The value will be changed. This value will be changed. This value will be changed. Now this will be changed. This will be changed. Okay? Everything will be changed now. How to do it? Let's use a different color. 470, right? So how much?
13.6.
Okay. 13.6. Very good. But remember, 13.6 is more than 10, right?
Yes.
So it is
Now we
enough.
can use
Now we can, like this. Now we can write it
10 volt.
equal to 10 volt,
Yes.
right? Equal to 10 volt because it is more than 10. Understand?
Yes, sir.
Now
Yes, sir.
now the Zener diode is on. Now the Zener diode is on, right? Since it is on, so some current will flow. So what is your IL? IL is equal to not VL.
BZ.
You can write VL or VZ, no problem, because VL is 10 volt now. So 10 volt divided by 180, right?
Not 180.
No, not yes, not 180. I forgot. I forgot to switch it up. How much? 470.
0.02.
10 divided by 470, 0.02. 0, 2, 1, 3. If you multiply by 1000, the value is 21.27. Okay, I can call it 21.3. 21.3 milliampere, right? That is the current.
Yes.
Now, what is your IZ? Obviously, IZ has a value. Now, you cannot find out the IZ first. Remember, now you have to find out the IR first. What is the formula? VR divided by R. What is your VR? VR actually this minus
VZ.
VZ, right?
Yes.
So
10.
VI is 20 minus VZ is equal to 10, right? Divided by 220. So 10 divided by 220.
0.04.
Yeah. 0.4545, something like that. If I multiply by 1000, the value is 45.45. Okay, now get back here, because according to the formula we know IR is equal to IZ plus
plus
IL. So can we keep that in this place and take that here as the subtraction?
yes, IR minus
So this will be IR minus
IR.
IL. So IR is equal to 45.45. IL is equal to 21.3 milliampere, right? So what is your
Yes.
answer? 24.14, 21.15, 24.15 milliampere. Okay. Now next question. Or we have found out all of those. Now, what is the maximum Zener current? Can you find out? Different color. What is the maximum Zener current? That means IZM. What is IZM? Sometimes it is given at maximum current, sometimes it is given maximum power. Okay?
Yes,
Sometimes it is given maximum current or maximum power. Here maximum power is given, so maximum current will be PZM divided by VZ. Right?
yes, 40.
Okay. 400 milliwatt divided by 10 milliwatt divided by volt. So 40 milliampere. Now how much current you have?
3 current, 4 current.
No. How much current you are actually having now? 24. So is it
24.15.
is it allowable?
Yes,
Yes, it is allowable because the maximum is 40. So you are getting 24.15, right?
yes,
So that's it. So actually solve the questions. Now next one. What? They said determine the value of RL that will establish the maximum power condition for Zener. Maximum power. That means, okay, let's come here. No, white. Determine the value of RL that will establish the maximum power condition of Zener diode. That means your IZM should be what? Maximum, right? So
yes,
that thing we have already found out. What is that? How much was the value?
40.
40 milliampere. So you have to find the value of RL so that your current is maximum. Okay? Current is maximum. So what current is maximum? This current is maximum, right?
Yes,
Remember,
Isaac.
this current is maximum. That means this current is what?
Minimum.
Minimum. If this current is minimum, what about this?
maximum.
Maximum. So RL maximum, right? You have to find out the RL maximum. Now what is your IR? IR is equal to IZ plus IL, right?
Yes,
Here, okay, let's use the green color. This is fixed. This is not fixed. This is not fixed. Here, if this is maximum, what about this?
minimum.
This is minimum. So we know this. We already know this. We have to find out this, right?
Yes,
Okay, let's find out. So how to do that?
V,
IR is how much? How much was IR? Remember the thing we have done earlier.
45.45.
Yeah, 25 point.
IR.
Yeah, IR. 45.45.
45.45.
Yes. Okay, what was IZM?
40.
40.
40. 40 milliampere. So how much is IL minimum?
5.5.
Right?
Yes, sir.
Now what about the RL minimum? Voltage divided by current, right?
Yes.
What is voltage? VL or VZ. What about IL? IL minimum. No, yes,
RL maximum.
I made a mistake here. This one should be maximum.
Yes, RL maximum.
This should be minimum, right? So VL is equal to 10 volt. We know it. You can write VZ as well. You can write VZ if you want. Okay.
Yes, sir.
Okay. Now IL minimum is equal to what? 5.45
4.5.
milliampere. So 10 divided by 5.45, 1.83. 1.835 kilo ohm. Okay, that is the maximum. That is the value of resistance that will establish the maximum power condition. You cannot go beyond this resistance. Okay, you cannot go beyond this resistance. Remember this. Okay.
Okay, sir.
Okay. Now I believe actually we are done with this Zener diode. You can find out. Okay, I have a homework for you. You do it at your home and give me the screenshot in the WhatsApp. Okay, can you do it?
Okay,
Yes.
sir.
And since your final term is coming, I will be giving you some suggestion so that you can practice at home. Okay. And we have one more big topic as well coming. So that is the BJT, bipolar junction transistor. In the next class, we will start the BJT. Okay, my dear?
Sir, okay.
Okay. So your homework will be this 44 math, 44, number 44. Can you see it?
Yes, sir.
So you can take a screenshot and share with your friends who are not attending the class. Okay. Thank you. Okay.
Okay, sir.
See you in the next class. Okay.